Hello everyone, welcome to the No Mystery Science channel, and before we start our solution step by step, please subscribe to the channel, like this video and share with your classmates. Now, let's go for our problem. Determine the internal normal force, shear force and moment at point E and F in the beam. So first, we're gonna start doing our equivalent load for the 300 newtons per meter. So we're going to have P is equal 300 times 6. So here P is equal to 1800 newtons is our equivalent load, and since it's a rectangle it's going to apply it here. So here we have our 1800 newtons. Now we're going to find our external forces. At point A, we have AY, AX. At point B, we have a tension pointing up, and here we have the same tension, but now we have TX and TY. So now we can start doing our second portion, that is the sum at forces in X is equal to 0, sum forces in Y is equal to 0, and the moments around the structure, sum of moments is equal to 0 as well. So here we're gonna start doing the sum of moments around point D. Remember that our counterclockwise is positive is equal to 0, and here we have 3 times our AY going clockwise, so it's minus, plus 3 times our tension is equal to 0. So from this equation we have AY is equal to tension. Now we're gonna use the sum of forces in Y is equal to 0. So here we have AY plus TY plus T minus 1800 is equal to 0. Everywhere we have T, we're gonna put AY. So here we have AY plus TY is AY times sine of 45 degree plus AY is equal to 1800. So here we have AY that multiplies 2 plus sine of 45 degrees is equal to 1800. So here we have AY is equal to T, that's equal to 664.9 newtons, that we're gonna say that 665 newtons. So discover our AY and TY. Now we can do the sum of forces in X is equal to 0. So we have AX plus T cosine 45 degrees is equal to 0. So here we have AX is equal minus, because pointing to the other way, 470.2 newtons, that we're gonna say that is 470 newtons. Negative is just the opposite way. Now that we find our external forces, we're gonna do our section cut at point E. So here we did our section cut. Remember that we have here a normal force E, a shear force pointing now at E, and then a moment going to that way, moment at E. Here we have our external forces AY, and then I'm gonna change the direction here for our AX, And then here now we have a new equivalent load that I'm gonna call in the very middle, I'm gonna call P1. So first we're gonna calculate our P1. P1 is equal 300 newtons per meter times 1.5. Our P1 is equal to 450 newtons. So that's our equivalent load at the midpoint. So now we're gonna use the same approach for the sum of forces in X is equal to 0. The sum of forces in Y is equal to 0, and the sum of moments is equal to 0. Here I'm gonna start with the sum of forces in X is equal to 0. Here I have normal E minus AX is equal to 0. So our normal force at point E is going to be 470 newtons. Now I'm going to proceed for the sum of forces in Y direction is equal to 0. Here we have AY minus P1 minus shear force is equal to 0. Here we have AY is 665 minus P1 450 is equal to our shear force at E. So our shear force at E is equal to 215 newtons. Now we discover the normal force, shear force. Now the sum of moments about E is equal to 0. So here we have ME that's going counterclockwise. Now we have plus 450 times 0.75, that's half of our 1.5, minus 665 times 1.5 is equal to 0. So our ME is equal to 997.5 minus 337.5. So our moment about E is equal to 660 Newton times meter. So now we finish our internal force at point E. Now we're going to finalize the exercise finding the internal force at F. Now we have normal force at F. Now our shear force is up because we are changing the side that we are doing, and the moment is going to the opposite way, moment and F. Here we just have our tension. So here is tension. Here is our P2. That's gonna be the same value as P1. So P2 is equal to 450 newtons, and our tension is equal to 665 newtons from part 1 and 2. Now we're gonna do the same approach. The sum of forces in X is equal to 0. The sum of forces in Y is equal to 0, and the sum of moments is equal to 0. Here we're gonna use sum of forces in X is equal to 0. The normal force in F is equal to 0 because we don't have any other force in this section cut. Now the sum of forces in Y is equal to 0. So here we have shear force of F plus our tension minus P2 is equal to 0. The shear force is equal to minus 665 plus 450. So our shear force at F is equal minus 215 newtons. The minus means that the opposite, it's opposite direction. Now the sum of moments in F is equal to 0. Here we have minus our moment F because it's clockwise, minus 450 times 0.75 plus 665 times 1.5 is equal to 0. Here our moment F is equal to 660 Newton times meter as well. So now we finalized our exercise. I hope you enjoyed this video. Don't forget to like the video and subscribe to the channel. Thank you. See you in the next problem.